Welcome to part 1 on dividing polynomials. The objectives in this section are 1. Perform long division to find a quotient, 2. Perform synthetic division to find a quotient, and 3. Use two important theorems to help draw the shape of a polynomial. Let's start with long division. Dividing polynomials is very similar to dividing numbers. Do you remember how to divide 128 by 5? How do you write it as a quotient and remainder? Let's just do a really quick review of that. If you have 128, this is the dividend. The number out front that you are dividing by is called the divisor. And the number you get at the end is called the quotient. We need to figure out how many times 5 will go into 128. If I look at 1, 5 will not go into 1, but 5 will go into 12 twice. So we say 2 times 5, multiply the 2 to the 5, and we say that's 10. Then I subtract what I just got from what I started with. This will give me 2. 12 minus 10 is 2. We find the difference. Then we drop 8 down. Now we have 28. And we do the whole process over again. 5 will not go into 2, but 5 will go into 28. 5 times 5 is 25. Multiplying the 5 to the 5 out front. And then we find the difference. 28 minus 25 is 3. This number is smaller than 5. And we have no more numbers to drop down unless we went into decimals. We're not doing that in this section. So this is called our remainder. Now, let's look at some rules and compare it to what we just did. Notice that we can write dividend divided by divisor equals quotient plus remainder over divisor. Let's see if we can write that in the form. So our dividend was 128. Our divisor was 5. And that equals our quotient, which is 25, plus the remainder divided by the divisor. This is 3 divided by 5. And so this is just like writing a mixed number. It's a fraction, improper fraction at first, then we write it as a whole number plus the fractional remainder. The other way you can rewrite this is the dividend, 128, is equal to the divisor, 5, times the quotient, 25, plus the remainder, 3. And if you check that, if you think of 25 as a quarter of a dollar, 5 times 25 is $1.25, so 125 plus 3. That will give us 128, which is indeed a true statement. So now we can use this same pattern to divide polynomials. Let's divide example 1 using long division. The example given is 6x to the third minus 19x squared plus 16x minus 4. We need to divide it by x minus 2. So the number at the beginning is the dividend, and the number second is the divisor. I'm going to rewrite this under the division bar. 6x to the third minus 19x squared plus 16x minus 4. Now we're going to put the divisor out front, x minus 2. And we are now going to do a little process off to the side. And you have to keep this little process going or the whole thing gets really messy and confusing. Off to the side, we take the first term of the dividend, divide it by the first term of the divisor, and simplify it. 6x to the third divided by x will give you 6x squared. You put that in the column directly above the degree that it matches. So this will go above negative 19x squared. We take the first term and we multiply it to each of the terms in the divisor. So if I multiply 6x squared to x, I will get 6x cubed. If I multiply 6x squared to negative 2, I will get negative 12x squared. Then I subtract everything that I just multiplied from what I started with. Notice that if I multiply by something, I am changing the sign of each one of my terms. So instead of distributing that and having a giant mess here, I'm just going to go through and put giant, huge, gross-looking signs that keep track of the sign changes that I just made. So this becomes a negative, this becomes a positive. Ta-da! Isn't it disgusting? Okay. But I know that I've changed the signs on my terms, so now I have 6x cubed minus 6x cubed. That goes to 0. And it will go to 0 every single time as long as you did the right work over here in your scratch paper. Now let's move on to the next one. Negative 19x squared plus 12x squared is negative 7x squared. Then I drop down the term that comes next to the right, plus 16x. And I do the whole process over again. I take the first term of my dividend, which is negative 7x squared. I divide it by the first term of my divisor, that's x. Then I get negative 7x when I simplify. I put that negative 7x in my quotient, and I multiply it now to each term in my divisor. Negative 7x times x is negative 7x squared. Then I multiply my negative 7x to negative 2. That gives me a positive 14x. Change my signs. The negative becomes a positive, the positive becomes a negative, and now I add my terms together. The first two add to 0. Haha, I did it right. My second two terms add to 2x, and now I drop down the next term to the right, which is a negative 4. And I do the whole process over again. So 2x is now my first term of the dividend. So 2x divided by the first term of my divisor, x, that gives me 2. Put that in the quotient. 2 multiplied to each term of my divisor will give me 2x, and 2 times negative 2 is negative 4. Changing the signs on the numbers I just found and adding gives me 0 and 0. My remainder is 0. Okay? And that's a good thing, because it means that x minus 2 is one of the factors of 6x to the third minus 19x squared plus 16x minus 4. We can now rewrite this as x minus 2 times 6x squared minus 7x plus 2. This is equivalent to what we started with. They are equivalent. Notice we have 3 terms in our divisor instead of just 2. So we do the same exact process again. The first part is my dividend. The second statement is my divisor. I need to find my quotient. I still need my scratch work off to the side. And the process is exactly the same, just a little more tedious. I take the first term of my dividend, 2x to the 4th, divide it by the first term of my divisor, x to the 2nd. That gives me a 2x to the 2nd to put in the quotient. Take that first term of the quotient and multiply it to each term in the divisor. That will give me a 2x to the 4th plus 4x to the 3rd minus 6x squared. Change the signs on all my terms and add them together. This gives me 0 in the first place, 0 in the second place, and negative 5x squared plus 6x squared is just an x squared. Now we can drop down the next 2 terms of my dividend. Plus 3x and minus 2. Now again, I do my little scratch work off to the side. Take the first term of the dividend, divide it by the first term of the divisor. That equals 1. X squared divided by x squared is 1. Put it in the quotient. Then I multiply 1 to each term of my divisor. That gives me an x squared, a plus 2x, and a negative 3. Now I change the signs on all my terms that I just made and add them to the row above. That adds to 0. 3x minus 2x is just x, and negative 2 plus 3 is plus 1. This tells me that it is not a perfect factor of the dividend, but I can rewrite this as x squared plus 2x minus 3, that's my divisor, times 2x squared plus 1, that's my quotient, plus the remainder, x plus 1, is equivalent to what I originally had. This is my remainder. Divisor. This is my quotient. And when you are asked to do homework questions, usually you're asked for the remainder, the quotient here, and the remainder here. Occasionally you will be asked for the fractional form, but they will usually make that very, very blatantly obvious. Let's try the last one. I particularly like this one because it's missing so many terms. We have an x cubed minus 1. So we're missing an x squared, so we'll say plus 0x squared. We're missing an x if we go in descending order of exponents. And then we have a minus 1. Our divisor is x minus 1. Over here on the side, we'll do our scratch work. Take the first term of the dividend, divide it by the first term of the divisor. That gives me an x squared. Put it in the quotient. Multiply the quotient term to the first two terms of the divisor, which gives me x to the third minus x squared. Change the signs. Add the terms together. Drop the next term down, even if it is a plus 0x. And then do the whole process over again. Take the first term of the dividend, divide it by the first term of the divisor, put it in the quotient. Multiply the quotient term to each term in the divisor. Change the signs. Add the term with the term above. Should come out as 0, and it does. And we have an x. Drop the next term down. Now we have x minus 1. Take the first term of the dividend, divide it by the first term of the divisor, gives me a 1, put the 1 in the quotient, multiply the 1 to the terms of the divisor. X minus 1. Change the signs. Add the terms together, and our remainder is 0. Ta-da! It worked. We had a remainder of 0. So our divisor, x minus 1, is indeed a binomial factor of x cubed minus 1. And if you remember your factoring of cubes, you probably already knew that.